so the steps are rewrite the equation of the form ax squared plus bx plus c equals 0. And then we're going to factor. And then we're going to use the zero product principle, which is right here. A times b equals 0, a equals 0, or b equals 0, or they both equal 0. Then we're going to solve, and then we're going to check our solutions. All right, so let's do number 1. Solve for the variable. Our variable is x squared, but it could be anything, right? So number 1 says x squared plus 9x equals 0. So we have it in the correct form. We have ax squared plus bx plus c equals 0. So now we're going to factor. So how can I factor this? Good. So Jabari says take out an x. What do I have common between the two? I have an x, right? So I can take out an x. If I take out the x, one of the x's, what do I have left? X plus 9, and that equals 0. So I've factored, right? And I'm going to use the zero product principle. I have the multiplication of two things. A times b equals 0. That means at least one of them has to be 0. So I'm going to set each of them equal to 0 and solve. Right? So I subtract 9 from both sides, and I get x equals 0 or x equals negative 9. Good? Okay, so let's do number 2. Number 2 says x squared equals 3x plus 10. So step 1 says I need to rewrite it of the form ax squared plus bx plus c equals 0. So somebody help me out. So we could subtract x squared. Then what? We could factor. So the thing is now is that we have a negative x squared, and usually we like to have positive x squared, right? When we factor. So we can just multiply everything by negative 1. I get 0 equals x squared minus 3x minus 10. If you would have subtracted the right-hand side to the other side, you would have gotten the same thing. So however you want to do it is fine. Okay, so somebody remind me how to factor. What am I looking for? So how do I factor? Can anybody remind me? I see a lot of people writing, so I know you guys know what's going on. What do I do when I'm trying to factor? So I need to, so it's called the AC method, where I have ax squared plus bx plus c. So I'm looking for factors of a times c that add up to b. That's what I'm doing when I factor. Factors of a times c that add to b, where I have ax squared plus bx plus c equals 0. So here in this case, my a is 1. So I just need to find factors of c, factors of negative 10 that add up to b, which is negative 3. So factors of negative 10 that add up to negative 3. So in my situation here, factors of negative 10 that add up to negative 3. So who's got an idea? What multiplies to negative 10 and adds to 3? Negative 5 and 2. So let's check. Negative 5 times 2 is negative 10. Good. And now let's add them. Negative 5 plus 2 is negative 3. So that adds up to my b term. So we're good. So this equals x minus 5 times x plus 2. Thank you, Peyton. Okay, so now I've factored. My next step is to set each term equal to 0, right? So I have x minus 5 equals 0. And x plus 2 equals 0. I'm going to add 5 to both sides. I get x equals 5. I'm going to subtract 2 from both sides, and I get x equals negative 2. So those are my answers. Do you guys feel okay about factoring? Should we do another example like this one? We have another, so this is an example where my a is 1, which is a lot easier. Here's an example where my a is not 1, so it makes it a little more complicated, but it's the same method. But we could do another example where a is 1 if you guys want to. No, we're good? Okay. All right, so why don't you guys start with number 13 or number 3 and see what you think. We have 15x squared minus 17x equals 4. What's the first step? Who can tell me? So we have to get it of the right form, right? We have to set it equal to 0. If you don't set it equal to 0, you can't do everything. All right, now we're going to do the AC method. So let me do AC. So I'm saying A times C. What's my A? What's my C? 15 and negative 4. What's 15 times negative 4? Negative 60. So I need factors of negative 60 that add up to my B term, and here my B is negative 17. What is it? Negative 20 and 3. Okay, so I'm going to multiply these just to check my work. Negative 20 times 3 is 60. Negative 60, good. Negative 20 times 3 is negative 17. So we're good, right? So now I'm going to rewrite my problem. I have 15x squared, and then I'm just going to use these two to rewrite my B term. Minus 20x plus 3x minus 4 equals 0. So I just rewrote my B term. Right? That's all that I did. So here's my AC method. Figured out my factors of A times C that add to B. And I use those to rewrite b. Okay? Does everybody see that? Yes? Okay, does anybody know what to do now? So now I'm going to factor by grouping. I'm going to say I have these two right here, and I have these two right here, and I'm going to see what's common between my first two terms. What's common between my first two terms? What can I factor out of these two? 5x. Okay, if I factor out 5x, what do I have left? 3x minus 4. And do I have anything common here? My second two terms? Just a 1, right? Nothing common, so I'm going to write 3x minus 4. I'm just going to put it in parentheses so that I can see the next step easily. So I just factored these two. Okay, so now between this term and this term, what do I have in common? The 3x minus 4, right? So I can factor out a 3x minus 4 from these two terms. What do I have left from the first term? It's 5x. And what do I have left from the second term? It's 1. So are we good? So this part, so this is the AC method right here, and then from here down it's called factoring by grouping. So if you need more practice with that, you can Google factor by grouping. If you need more practice with the above, you can Google the AC method, or you can come to my office hours, of course, or tutoring, or whatever. Okay, so now I've factored, right? So now I'm going to set each term equal to 0. So I have 3x minus 4 equals 0, and I have 5x plus 1 equals 0. So here I'm going to add 4 to both sides. I get 3x equals 4. I'm going to divide both sides by 3. And I get x equals 4 over 3. Good? The second term I'm going to subtract 1 from both sides. Then I'm going to divide both sides by 5, and I get 2 answers. Are we good? So this from here down, from here to here, is factoring by grouping. Right, I'm having a little group here and a little group here, and I'm seeing what's common between them. The goal is to get it so that you have 2 of the same things so that you can factor that out. If you get to here and you don't have 2 of the same things like this, then you can't factor out a common term. Okay? So, unless you guys want to do another example, we're going to keep going. Do you guys want to do another example like this? All I'm seeing are no's. So, if you do want to see another example, you have to speak up. Okay? All right, so now we're going to use the square root property. So the square root property, if u is an algebraic expression and u squared equals d, then u equals plus or minus the square root of d. So we're just using, so this is a little simpler because I have perfect squares. And I can just take the square root instead of doing the factoring stuff and all of that. So number 4, I have x squared minus 9 equals 0. So this is just basically saying I can add 9 to both sides. I get x squared equals 9, and then I can take the square root of both sides. So let me make that as another step. What's the square root of 9? What is it?
3.
It's plus or minus 3, right? So we have to do plus or minus. Okay? So number 5. So basically, I'm isolating here. I wrote u squared, but here I'm isolating my variable, right? That's all it is. I'm isolating my squared term. Once I isolate the squared term, then I can take the square root of both sides. So number 5 says 4x squared equals 20. So I want to isolate my squared term. Who can help me? So I have x squared. I can add 20 to both sides. I don't have my squared term yet. I have 4x squared, so I can divide both sides by 4, and I get 5. Right, so I'm not writing my adding and subtracting and dividing anymore. We're week 4. We all know what we're doing, right? So let me write an additional step. So once I've isolated my squared term, I'm going to take the square root of both sides. Okay? Can I simplify the square root of 5? No, it's just ugly. So just leave it. All right, so number 6, I have x plus 3 squared minus 16 equals 0. So I need to isolate my squared term. So in order to do that, I can add 16 to both sides. Now I've isolated my squared term, right? Because I have something squared on the left side. So let me write, I'm going to take the square root of both sides. So on the left, the squared and the square root cancel each other out, right? So on the left-hand side, I get x plus 3, and on the right-hand side, I get plus or minus what? 4. Good. All right, so now what should I do? Subtract the 3 over. So I get x equals plus or minus 4 minus 3. So how can I write that as two numbers? I get x equals 4 minus 3, and x equals minus 4 minus 3, right? So I have my plus 4 and I have my minus 4, and I'm going to see what my two answers are. So 4 minus 3 is 1. Negative 4 minus 3 is negative 7. So those are my two answers. Okay, so those are two ways to solve quadratic equations, right? We can use the square root property if we can isolate a squared and have a number on the other side, right? Here we isolated our squared term. We had a number on the other side, and we took the square root of both sides. Don't forget that plus or minus, right? Before that, we factored and solved. And a third way to solve quadratic equations is using the quadratic formula. The good old quadratic formula. So again, I have a quadratic equation, ax squared plus bx plus c equals 0. Then I have x sub 1, x sub 2 equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So that a, b, and c, that all comes from these constants, right? The coefficients that are in front of the variables. So a is always next to x squared, b is always next to x, and c is always the constant by itself. So basically, as long as we get it equal to 0, we get our quadratic equation equal to 0, write down what a, b, and c are, then we just plug it into the quadratic equation, right? So factoring is very nice. Factoring doesn't always work, right? The square root, doing the square root thing that we just did, that's also nice, but it doesn't always work. The quadratic equation always works. So if you have to remember one thing from this class, it's the quadratic equation, and you need to memorize this formula, right? Okay, so let's do the examples. Number 7. I have 5x squared plus x minus 2 equals 0. So what's my a, what's my b, what's my c? A is the number next to x squared, so in this situation it's 5. B is the number next to x, so in this case it's 1. And c is the number that's by itself, the constant. In this case it's 2. So I have 2 roots. I can have up to 2 roots, right? So that's what this, x sub 1, x sub 2 is. It's a little subscript down next to the x. Just means I have 2 possible roots. And I'm just going to plug it in. So let's say this is a test. When is your guys' first test? Monday. We have a test on Monday, right? In 1 week. So if this is your first test, I would say the first thing you would do for your first test is to write down the quadratic formula. Say, hey, I know something, right? First step would be write down the quadratic formula and then plug your stuff in. Because once you write down the formula, you're saying I know something. If you plug something in a little wrong, then it's not as big of a deal once you do say what you know, right? So I would write down the quadratic formula. We have it right here, so I won't. And then I would plug in my a, my b, and my c. So I have negative b, so it's negative 1 plus or minus the square root of b squared. Make sure you're putting that squared term in parentheses, because if you type it into your calculator and it's negative, you've got to have it in parentheses, okay? Minus 4 times 5 times negative 2. So 4ac all over 2a. So I have negative 1 plus or minus the square root of 1 squared, which is 1, minus 4 times 5 times negative 2 is what? So it turns to positive 40, all over 2 times 5, which is 10. Okay, so here I'm going to have the square root of 41, right? I can't simplify that. 41 is prime, right? The only 2 factors of 41 are 1 in itself. So it's ugly, so I'm just going to leave it. Negative 1 plus or minus the square root of 41 over 10. Don't really think I could simplify that. The only way The only way I think that I could, why don't you guys tell me when that happens? Once I moved it up, everyone's like, oh. Okay. The only way I see that I could simplify this is writing 2 different fractions. So if I'm adding and subtracting in the numerator, then I can rewrite that as negative 1 over 10 plus or minus the square root of 41 over 10. And that's only good when I'm adding and subtracting in the numerator. If I was adding and subtracting in the denominator, I could not write that. I could not do that little split up thing. Okay? I think you guys have done this stuff a bunch, yeah? Okay, so let's talk about what we're actually doing when we're solving quadratic equations. So, does anybody know what we're doing when we're solving quadratic equations? I know somebody does. So if we're solving quadratic equations and we're setting the equation equal to 0, what does that mean our y value is in this situation? If I wrote this as a function, like f of x equals ax squared plus bx plus c, I'm actually setting f of x equal to 0, right? What is f of x? That's the y value. So where does y equal 0? On the x-intercept. So here's a picture of what we're doing. We're finding the x-intercepts, right? When we set it equal to 0, we're finding the x-intercepts. So we could have 2 real solutions, we could have one solution, and we could have 0 solutions, right? So you could have 2 solutions, 1 solution, or 0 solutions. So what does that mean about checking your work for these problems? Is there a way to do that? What is it?
Plug in your x values that you get.
So you could plug in your x values into your original equation.
Right.
So is there a way to check your work? So you can check your work like that. Is there another way to check your work? Like, let's say you're on a test and you're going, oh my goodness, I forget how to do this. Is there some way you can, like, use your calculator? Somebody help me. I'm giving you guys some shortcuts. Well, let's see. This picture says if I graph it, I'm looking for my x-intercepts. Is there a way to locate x-intercepts in your calculator? Yeah? How? Let's do it for, like, number 6. No, let's do it. Yeah, we'll do it for number 6. Is there a way, can somebody show me how to find x-intercepts in my calculator? Okay. Well, it looks like you guys can have something to Google then. So there's a way to check your work if you know how to find the x-intercepts in your calculator, because that's all we're doing. When we set it equal to 0, right, this is actually our f of x value, which is actually our y value. F of x equals y, right? So I'm finding my x-intercepts. If you can figure out how to do that in your calculator, then you can check your work. Okay, so let's continue talking about the quadratic formula then. So for the quadratic formula, I'm going to talk about the discriminant. The discriminant is b squared minus 4ac. The discriminant is that part underneath my square root, right? b squared minus 4ac. So if that part is positive, it tells me I have 2 solutions. If that part equals 0, I have 1 solution, right? So if this part is 0, I just have negative b over 2a. That gives me 1 solution, right? Because the square root of 0 is 0. If the discriminant is negative, I have no real solutions. I have imaginary solutions, right? Because if I have a negative under the square root, we always say that that's not allowed. So we're just going to say no real solutions. That means it doesn't intersect the x-axis. Okay? So the next couple examples say determine the number of solutions. So we don't need to do the whole quadratic equation for these ones, right? We just need to look at the discriminant to see if the discriminant is positive, 0, or negative. Well, for number 8, we already did all the work up at the last question, right? We did all the work at number 7. We got the discriminant, b squared minus 4ac. We got that equaled 41, right? So this is from number 7. So from number 7, we got that the discriminant equals 41. That's positive, greater than 0. So we have two solutions. Right? And that's what we got up here, right? We got 2 solutions, but if we wanted to look at just the discriminant, if this is the question, you don't need to solve all of this stuff. You just need to look at the discriminant.
It's not the same question.
Yeah. It's plus
Oh.
27 minus 2.
Okay, so let's do it. Thank you. Thought that's how I made it. Okay, so it's not the same question. So in order to see what A, B, and C equal, I need to make sure that my equation equals 0, right? My equation here equals 0, so I can just plug in. So what's my B? 1. So I have B squared minus 4 times A, which is what? 5 times C, which is 2. So I have 1 squared minus what's negative 4 times 5 times 2? Negative 40, so that equals negative 39. Which is, it's less than 0, right? So it's less than 0. So that means I have no real solutions. And that means if I graphed this function, it would not intersect the x-axis, right? So no solution. So it says determine the number of solution, 0, right? The number of solutions is 0. Okay, number 9. X squared plus x equals 6. First step is I need to get it equal to 0, right? So everybody do that on your own. And then write down what A and B and C are. Check my work, make sure I got it right. Are we all on the same page? Yeah? So now I need to look at the discriminant. That equals B squared minus 4AC. So I have 1 squared minus 4 times 1 times negative 6. Which equals 1 plus 24. Which equals 5. So then going back up to my chart up above, it's positive, right? It's greater than 0. So 2 solutions. Is that good? Oh, I was doing the square root of it. Sorry. Sometimes I do that. So that's the one under the square root, right? That's why I did the. But for the discriminant, we're not looking at the square root, right? We're just looking at this number. Thank you. Okay, number 10. Why don't you guys do it on your own? I'll write it down. And then check my work. Did I get it right? Yeah. Oh. Do you guys want to do any examples of more stuff, or should we move on to 1.5? We still have 5 more minutes. Are you guys good with factoring? You guys good with the AC method, the quadratic equation, and then this discriminant stuff? So this discriminant stuff is just much quicker than figuring out the whole quadratic equation, right? So that can save you a lot of time on a test. All right, well, let's start. Let's start 1.6 then. Can I take this? Is everybody done writing? Okay, so 1.6 is other types of equations. So 1.6 is other types of equations. Here we have radical equations, an equation where the variable occurs inside a root. So the steps to solving are isolate the radical, raise both sides to the nth power to eliminate the nth root, and then solve and check the solutions. You may need to repeat steps 1 and steps 2. Okay, so number 1 is super easy, right? I have the square root of x. So how do I solve that? Well, what's the root on x? What's that power? 1/2. So I'm going to square it. I'm just going to write another step. I'm going to square both sides. Because if I was looking at rules of exponents, x to the 1/2, x squared, right? We talked about this a while ago. If I have x to the 1/2 squared, I multiply those, right? So 1/2 times 2 is 2 over 2, which equals 1. And so that's why if I have the nth root, I'm raising it to the nth power, is because it cancels it like this. It's rules of exponents that we talked about the first class. So here I get x equals 144. Right? So number 2, again, the first step is to isolate the radical. I need to get the square root by itself. So here I'm going to add x to both sides. Once I do that, I'm going to raise both sides to the nth power. Here, my square root is actually, that n is 2, right? Because it's that, the square root is the 1/2 power. So let me rewrite, just so I can show that that's what I'm doing. Okay, so then on the right, on the left-hand side of the equation, I'm left with x minus, or 1 minus x. On the right-hand side, what do I have? Good. So Jabari says x plus 1 squared is x plus 1 times x plus 1, right? So I need to do the good old FOIL. So who can tell me what to write? X squared plus 2x plus 1. So I FOILed and I combined my like terms. Okay? So now what do I have? What kind of an equation do I have here? It's a quadratic, right? It's a degree 2 equation. I have x squared, degree 2. So I need to solve it like I solved it in the last section. So that's where we'll leave off today, and we'll start next class. If you have questions, let me know. I have office hours today.